We are going to take a look at a question on this experiment adapted from 2011. The first thing to note is the dilution factor we just described. Here, 25 centimeters cubed is diluted to 500 centimeters cubed, which if you divide 500 by 25 gives us a 1 in 20 dilution factor. After excess acid and iodide ions are added to give us our iodine solution, it is titrated against a 0.1 molar thiosulfate solution, and we have an average titer of 16.1 centimeters cubed. Note, as we said before, that we will ignore the iodine and pretend that we are titrating directly the diluted bleach and the thiosulfate, and that these two react in a ratio of 1:2. So we can start with the dilution of our bleach. 25 centimeters cubed is diluted to 500 centimeters cubed, which represents a 1 in 20 dilution, as we said. We make up this solution in the way we have just outlined. We can now set up our solutions for the titration. In our burette, we will have 0.1 molar sodium thiosulfate. We will transfer 25 centimeters cubed of our diluted bleach to the conical flask, and as we described earlier, we will add excess sulfuric acid and excess potassium iodide. We can then carry out the titration as we did in the previous mandatory experiment, where we will see the colour of iodine fade gradually as we add thiosulfate. When it is straw yellow, we will add starch, which will give us a deep blue-black colour, and this will disappear suddenly, giving us the sharp endpoint that we need. Here we see that we have an average titer of 16.1 centimeters cubed. We can now find the number of moles of our standardized 0.1 molar sodium thiosulfate in this 16.1 centimeters cubed, and it comes to 0.00161 moles. We can now look at our reaction as we described before as if it just happened between hypochlorite and thiosulfate, and iodine is not involved at all. They react in a ratio of 1:2, so we will divide the number of moles of thiosulfate by 2 to get the number of moles of hypochlorite. This comes to 0.000805 moles. We can now answer the first part of our question to find the concentration of sodium hypochlorite in the diluted bleach. We have the volume and the number of moles, so our concentration will come to 0.0322 molar. To find the concentration of sodium hypochlorite in the original bleach, we will need to simply multiply the concentration of the diluted bleach by the dilution factor of 20, and we get 0.644 molar. For part C, to convert from moles per litre to grams per litre, we will need to multiply by the molecular mass of sodium hypochlorite, which is 74.5, and we get 47.978 grams per litre. Finally, for the last part, to express the same concentration as percent weight per volume, or grams per 100 centimeters cubed, we will simply need to divide by 10 to change from litres to 100 centimeters cubed, and we get 4.8%. That's it for mandatory experiment 8.5, and for all of our redox volumetric analysis. Have a go at some of the past paper questions.